Hello everyone and welcome back. In this lecture we are diving into section 3.2 Nodal analysis, one of the most important and efficient methods for analyzing electrical circuit. The technique uses Kirchhoff's current law KCL to solve for unknown node voltage in a circuit. It works best when the circuit has many elements connected to the common nodes. Let's break down that one step by step. What is the nodal analysis? Nodal analysis is technique based on KCL, which states that the algebraic sum of all currents entering to the nodes is zero. Rather than solving for every current in a circuit, nodal analysis focuses on solving for node voltage, which often simplifies the math. Let's do the steps in the nodal analysis. We have 3 steps. The first step is to select a reference node. First of all, we are going to find number of nodes over here. So we know that we have one node here, we call it node 1. We have another node here, we call it node 2. And there is another node here. I'm calling this one as a reference node, which is grounded. You call it grounded as well. And symbolically, you show the grounding by this or by that, meaning that this is grounded. And for the ground, the voltage of the ground is assumed to be 0. This is the first thing. So first step is to find the number of labels, the number of nodes, and we label it each node. Here we have 3 nodes, and I'm going to call it 1, 2, and 0, because one of them, which is the 0, we call it as a reference node, which is grounded. The second one is for non-reference node, we are going to label them as V1 and here V2. So we are going to assign the voltage variable to these nodes. And finally, in the step 3, we are going to apply KCL to each non-reference node. And we are going to consider that the current over any nodes can be found in that way. I is equal to, because we know that the current follows from the higher potential to the lower potential in the resistor. So therefore we can write I as V, which has the higher potential, minus voltage of lower over the resistor value. So in this regard, assume that I have the circuit like this, and I'm going to solve this circuit applying the nodal analysis. First of all, I'm going to add some current for the branches that doesn't have any current. So here I can add, let's say, I1 with the lowercase, which is different from I1 with the capital script. So I'm going to also add I2 here in this branch, and I'm going to add I3 in that branch. So what is the first step? The first step to do the nodal analysis is, I'm writing here, finding all nodes. Here I have 3 nodes, 1, 2, and the third one, which is I call it as a 0, which is label it as 0, which is my ground, and I call this one as a 0, and I call it as a ground. And in this book, we are going to show the ground like this, or also it is possible you see like that. Okay, so we are going to find all nodes. Here we have 3 nodes, node 1, node 2, and the last one, which is the ground. Then the next step is to label non-reference one. Non-reference node. Here, node 1, I call node 1 as V1, label it as V1, and node 2, I label it as V2. Then the third step is to apply KCL on each node. I'm going to apply KCL in node 1. So KCL in node 1. As you can see, I1 is entering to this node, Y. The other I1 and I2 are leaving. So I1 is equal to I1 in the lowercase plus I2 lowercase. What else? I have this one, the big I2. So also big I2 is also leaving. So therefore this is equal to I1 plus I2 plus I2. Now I can also apply KCL in node 2. What I have there? In node 2, I notice that I2 is entering, this I2 also entering, while I3 is leaving. Therefore, I2 plus I2 is equal to I3. Now, I'm going to write everything in terms of Ohm's law. I'm going to write the lowercase I1, I2, and I3 in terms of Ohm's law. So what is I1? If you look at I1 over here, I1 is nothing but the voltage difference, which is V1 over V0, V1 minus V, because we know that according to this definition, the current goes from the higher voltage to the lower voltage. The voltage at the reference is 0, and the voltage that I have in label 1, we call it V1. Therefore, I have V1 minus V0 over the resistor value, which is R1 here. Therefore, my I1 is going to V1 minus 0 over R1. So I1 is giving me V1 over R1. What about I2? I2 is, I redraw this circuit just for I2 section. So this is my I2. I2 and this is the resistor R2. Here what are our labels? Here we have V1 and here we have V2. Here we have V1 and here we have V2. According to the equation, we are assuming that voltage in V1 is higher than voltage in V2, so I can say that V1 minus V2 over R2. And what about I3? I can say, again, I3 is this one. I3 is going to be equal to voltage at the higher one, which we call it V2. This is V2 minus voltage in the lower one, which is they're using the same node, which is 0 minus 0 over R3. So now since we have I1, I2 and I3, we can replace this value and add it to this equation that I am calling equation 1 and equation 2. So therefore, what is my I1? My I1 is equal to I2 plus, what is the I2 in the, what is I1 and I2? I1 is going to be V1 over R1. And what is I2? I2 is V1 minus V2 over R2. And what is the second equation? Second equation, it says that I2 plus I2 lowercase plus I2 lowercase, which is V1 minus V2 over R2 is equal to I3, which is equal to V2 over R3. So up to here we have these ones, and we may also write this one in terms of conductors. If we want to solve this problem, solving this one in the conductance form is look easier, because I can write I1 is equal to I2, and I know that the conductor is the receptacle of the resistance. Therefore, I can write this one as G1 V1 plus G2 V1 minus V2. And for the next one, I can write I2 plus G2 V1 minus V2 is equal to G3 V2. Okay, and I can rearrange this equation. I can say that I1 minus I2 is equal to G1 V1 plus G2 V1 minus G2 V2, and I can write this one as I2 is equal to G3 V2. So it's going to the other side, minus G2 V1 plus G2 V2. Then I can even write this one as a matrix form in order to solve that one with other methods that I explain later on. So if I want to write this one in the matrix form, I can create a matrix form for G. What I have for V1 and V2, here I have V1 and V2. In the first equation, for V1, I have G1 plus G2. Yes. and here I have minus G2, and for the next one I have for V1 I have minus VG2, and for V2 I have G2 plus G3 times this one is equal to I1 minus I2 over I2. So in that case, I'm going to solve this problem using the Cramer's rule, for example, and even I can give these matrices to some software packages like MATLAB, MATCAD, and Maple in order to solve the problem. So this is for today, and thanks a lot for watching this video. Please, if you like this video, please again like, subscribe, and let me know your question in the comment. Thanks for watching and see you next time.